couple requests for people that want some things worked to kind of see if they're on the right track. So we're going to start with number 3. Number 3 is kind of a doozy. Well, we need a little bit of room for this one. So when we start with cotangent, remember you want to try to write things in the simplest form possible. So like getting things to sine or cosine. So if you use your identity sheet, cotangent squared, you can rewrite it as cosine, of course it has to be squared because this one's squared, of x over sine squared of x. So that's on your quotient identities. For secant, you can rewrite it as 1 over cosine squared of x. And then for tangent, again, it's the reciprocal of the first one we did, the cotangent. So we have sine squared of x over cosine squared of x. So then we're going to start from there, and we got to think about, these are adding and subtracting fractions, so we've got to get like denominators. So we have a sine squared, these don't have a sine squared, and we have a cosine squared, and these two do, but the first one doesn't. So our common denominator is going to be the sine squared x, and you can put them in parentheses, you want our times cosine squared of x. All right, so the first piece here, if we're talking about this first here, it had sine, but not the cosine. So cosine squared times cosine squared gives us cosine to the 4th x. The second one had the cosine squared, so it's just the sine, so it's going to be the plus sine squared of x. And then the last one had the cosine squared, but not the sine, so it's going to be minus sine to the 4th of x. So then we can look about what we combine in same places. So when we look here, we can think about, well, what can we do with what we have? Now, I like to put them in the right order, so it's kind of like, like terms together are the biggest coefficients together, or exponents in this case. So cosine to the 4th minus sine to the 4th. X is in there. And then plus sine squared. And that just puts them in order for me. It's nothing, you don't have to do that. It's just something I do to keep things straight in my mind. All right, and then our denominator is still the same, of course. So from here, we got a factor. So we can think about how can we rewrite, if we think about this section right here, and this is one of the reasons I put them together, I can think about what can I pull out, or how can I rewrite those to be in terms that'll help me cancel something. So when I look here, I can say, oh, well, I can do cosine squared of x minus sine squared of x. And that's like being squared, so I can write that where no middle term would happen. So I'm just rewriting this as 2 binomials. So then this one would have to be cosine squared of x plus sine squared of x, because when I multiply those back, it would have no middle term, and it would cancel out and have a negative. So one's negative, one's positive. And then I have my plus sine squared of x. And it's still all over my common denominator. All right, then from there we think, what can we do to get rid of some stuff, or to simplify? So when we think about what's going to happen here, look at our things that are squared and things that are not squared. So we can think about our identities, our Pythagorean identities. Do any of these meet a Pythagorean identity? Well, this here with our plus actually equals 1. So we're going to rewrite that. So we have cosine squared of x minus sine squared of x times the 1 plus sine squared of x, and still all over our common denominators. All right, so once we have that, then we say, well, can we, simplify anything else? Well, obviously the 1 doesn't change anything. That just changes the cosine squared x plus sine squared x. And then what we end up having if we simplify the top is cosine squared x minus sine squared x plus sine squared x all over our common denominator. And then from there, we can start reducing. So if we look here, we can say, well, what can we get rid of? So if we look at the first things that are the same, we can actually get rid of, because this has happened to all pieces. We can get rid of this sine squared, a negative sine squared too. So this piece right here and this positive, they will reduce out to 1. Okay, so what we're left with is cosine squared of x all over sine squared of x times the cosine squared of x. Then these cosines will actually cancel out and you get 1 over sine squared of x. And then this is a reciprocal of the cosecant. So this would write down to CSC squared of x. For number 4, we want to get them again in simplest forms of sine or cosine. Sine's already fine, but cotangent we're going to rewrite as its quotient identity. So cosine of theta all over sine of theta. And this is multiplying times sine of theta. You can think about this over 1 if you want, but we can cross reduce here, and we're left with just the cosine of theta. Number 6, look for all the ones that are already written pretty simply. So we have sine, it's simple, tangent's not, cotangent's not, and cosecant's not. So let's rewrite those in its simplest form. So we can make them all look like fractions if you want. They're all being multiplied. So tangent in its simplest form with sine or cosine is sine x over cosine x. Cotangent is reciprocal of that, so cosine of x over sine of x. And then cosecant is 1 over sine of x. So now we're multiplying all these together so we can do cross-reducing or reduce as we go. So I have a sine of x here and a sine of x here can go away. I have a sine of x here and a sine of x here can go away. I have a cosine here and a cosine here can go away. So this is just 1 over 1, which equals 1. So we start here and we look at the top and we say, is this identity or is this something I can rewrite differently? And if you notice, this is the plus, so this is like Pythagorean theorem. This actually equals 1. So it's 1 over cosine squared of x. And then this one can be written as its reciprocal of secant squared of x. First, we can think about how can we write these in terms of sine or cosine. Well, secant itself can be rewritten as 1 over cosine of x. Sine is already in a simple form, so we can write it as sine of x, and we want to make it a fraction, we can write it a fraction. And then tangent, we can write as sine of x over cosine of x. So now we look and see what can we do and simplify. So these are being multiplied right here. And so we want to simplify that. So 1 over cosine of x, and then we have sine x and sine x. So that gives us the sine squared. So minus, we have sine squared of x all over cosine of x. Just multiply straight across. So then we think, okay, we have some common denominators. Great. We don't have to do that. And we're going to go ahead and combine. So this ends up combining to 1 minus sine squared of x over cosine of x. And then if we look again at this, we think, oh, there's a property there that we can use on Pythagorean. So 1 minus sine squared of x is the same thing as cosine squared of x all over cosine of x. And then we have 1 down here and 2 up here. So this reduces, this goes away, and this reduces to 1. So we're left with just cosine of x. All right, number 10. Again, we want to start with, can we write these in terms of sine or cosine equally? Well, this one's already cosine, so the bottom's going to stay cosine. But tangent and secant are not in any form of sine or cosine. So let's rewrite them in the way they are. So using your trig identity sheet, tangent squared of x can be rewritten as sine squared of x over cosine squared of x. And then the secant can be written as 1 over cosine squared of x. I always remember, even though the sheet has only got it in one term, if you're doing with the square, you have to write it as a square. And then cosine of x stays on the bottom. So then we're going to go ahead and think about, can we combine these? Well, the top pieces, so these top numerator up here, we're combining them fractions. They already have like terms, so let's combine them here. So we end up having sine squared of x minus 1 all over cosine squared of x, and then the cosine of x stays on the bottom. Well, then look at your identities. This is a Pythagorean identity, so we can actually write it, and this one's a little bit trickier because usually it has a plus, but if you move signs around, you would end up having a negative cosine squared of x is what this equals, okay? The top part, all over cosine squared of x. That simplifies down to a negative 1. And we have cosine x, and it just keeps coming over because we haven't done anything to it. And then this here simplifies down to a, if we didn't have the negative, it would just be a secant of x. But because we have a negative, it's a negative secant of x.